Okay, Chapter 10 test. Problem number 1 asks about what angle 2 is best described as. Well, we only know about two types of angles that have names. We know about central angles, like this angle 2 here, whose vertex is at P, is a central angle. Its vertex is at the center of the circle. And so is angle APC, for instance. The angles that have their vertex on the circle, like angle 1, angle ADB, angle ABD, those angles are called inscribed angles. So angle 2, because its vertex is at the center, is a central angle, choice A. Problem number 2 asks about angle 1. Well, angle 1 was one of those angles whose vertex, in this case A, is on the circle. That's an inscribed angle. So the other words that were in the list of choices, palindromic angle and semicircle, were just in there to see, if you knew what the right one to choose. Problem number 3 asks about segment AD, in which it's best described as. Segment AD connects 2 points on the circle. It's called a chord. Segment AB is also a chord, but it has a better term. It's a diameter. So problem number 3, segment AD is a chord. Choice A. Problem number 4, segment AB is a diameter. Choice B. Problem number 5 asks about segment PC. PC starts at the center of the circle and goes to a point on the circle. That makes it a radius. And a radius was choice E. Other radii shown in the picture are segment PB, segment PA. Number 6 asks about line EF. Line EF out here is a line that intersects a circle in a single point. The name for that is a tangent line. So that was choice D as in dog, tangent line. Number 7, line AD. Earlier we talked about segment AD, which is a chord. Line AD is a line that intersects a circle in 2 points. It's called a secant line. So we have two types of lines intersecting circles. Secant lines intersect circles in 2 points, like line AD, and tangent lines intersect a circle in exactly 1 point, like line EF. So number 7, line AD was a secant line. Number 8, arc DB. Arc DB is a 30-degree arc. It starts at D and ends at B. It's smaller than a semicircle, so it is a minor arc. Also, any arc less than 180 degrees is automatically a minor arc. Number 9, arc DBA. Starts at D, goes around through B, and all the way to A. It's 30 degrees and then plus another semicircle. It's bigger than a semicircle. It's 210 degrees. It's a major arc. Major arcs are larger than 180. So that was number 9, was a major arc. That's B. Problem number 10, arc ACB. Arc ACB starts at this end of a diameter, goes through C, and ends up at that end of a diameter. It is a semicircle. And arc, the center of circle P is the point P. That's problem number 11. If you got off on what letters were answers as we went through that, the key is on Prism. Okay, problem number 12, we're still dealing with figure 1. Asked to find the measure of arc AD. Well, if we look at this lower semicircle that starts at A, goes around through D, and ends up at B, semicircles are 180 degrees. So if we've used up 30 degrees here, 180 minus 30 gives me 150 degrees for this arc. So this arc is 150. And that is choice C from your list. Number 13, the measure of arc ADB. Arc ADB starts at A, goes around through, ADB, starts at A, goes around through D, and ends up at B. Well, it starts at one end of a diameter and ends at the other end. It is a semicircle, 180 degrees, choice B. Number 14, ask about the measure of arc ADC. Well, that starts at A, goes through D, but it goes all the way up to C. It is 180 for the semicircle plus another 80. The answer is 260 degrees. That's choice D on number 14. Number 15. if we add together arc AC, which starts at A and goes to C, and we add to that arc ADC, which essentially, if I do AC, if I take a look at this circle, start at A and C, the other one is ADC, which starts at A, goes through D, and ends at C. That's the whole circle. That's got to be 360 degrees. That's choice B. On number 15, that's choice D as in dog, 360. The measure of angle 1. Angle 1 has its vertex on the circle. The rule for when the vertex is on the circle is the angle is half the arc it intercepts. It intercepts a 30-degree arc, so it must be a 15-degree angle. That's choice A for number 16. The measure of angle 2. Angles 2 is vertex is at the center of the circle. If the vertex is at the center of the circle, then the measure of the angle equals the measure of the arc. The answer is 80 degrees. That's B for number 17. Number 18, the measure of angle ADB. Start at ADB. Notice that as you're talking about this angle, if I go out this direction, I hit the point B. That's one end of a diameter. I go out the other direction, I hit the point A. The part of the circle that's inside of that angle is a semicircle. Since its vertex is on the circle, like angle 1, its measure is half the arc it intercepts. Since it's intercepting a 180-degree arc, its measure is 90 degrees. On number 19, we're dealing with the measure of angle FAD. Angle FAD starts at F, goes to A, and over to D. And so I'll put a little arc across it. That's the angle that we're talking about right there. Now, technically, it's not called an inscribed angle, but its vertex because its vertex is on the circle here at A, it follows the same rule that angle 1 does, who had its vertex on the circle. It's half the arc that's inside of it. The arc that's inside of it is this 150-degree arc. So its measure is half of 150. Its measure is 75 degrees, and that was choice B. The next series of problems, 20 through 23, use figure 2. Now, number 20 says, suppose the measure of angle 1 is equal to 100 degrees. And the measure of arc RV is 80. Then what's the measure of angle 2? Well, the measure of angle 2 really only depends upon the measure of angle 1, and it really has nothing to do with circles. Angle 1 and angle 2 are side by side along a straight line. They form what we call a linear pair, and since the start of the year, those guys have added up to 180. So the answer is it is 80 degrees because these two add up to 180 always. And 80 degrees is choice A. Number 21, the measure of angle 1 again is 100. The measure of arc RV is 80. And now we want the measure of arc TS. Well, we have I called that X here for arc TS. We have a rule that says when the vertex of the angle is inside the circle, but not necessarily at the center, that angle, this 100 here, intercepts an arc, 80. Its vertical intercepts an arc, which is our X degree arc. The rule says to get the angle, you add the arcs and divide by 2. So the math you want to do is you want to say 100, that's the angle, is equal to the arcs added, 80 plus X over 2. You solve that for X. That's 200 equals 80 plus X. And now you have X being 120. So the answer there is 120 degrees, which I do not see on the list. So let me just go through 80, 160, 10. So this answer is E, none of these. The answer was 120, but didn't appear. On number 22, the measure of arc VS is given to us at 60 degrees. And the measure of angle 2 is 80. And the measure of arc TR is 80. So that's this arc. And we want the measure of angle 2. So I'll sort of scratch out the other stuff that we'd used before in the problem. So what you have here is you have an angle that you want. It intercepts a 60-degree arc. its vertical intercepts an 80-degree arc using the same rule that we used before, the angle, this time angle 2, is equal to the arcs added. That's 80 plus 60 over 2. That's 70 degrees. And 70 off of our list is choice D on number 22. 23 deals with segments in this picture. Change up colors so we can see what's going on here. RX is 10. This segment right there is 10. Okay. XS is 8. Right there is 8. TX is 16 right here. And VX is what we want to find. Let's call it Y and put a variable on it. Okay, we have another rule. The rule says that when two chords cross inside a circle, they will divide each other up into pieces. And the pieces of chord RS in this case multiplied together will multiply to the same thing as the pieces of chord TV. So what we get is 16 times Y, 16Y, is equal to 10 times 8. So that 16Y is equal to 80, and if you divide, you will get Y being 5, which was the missing part that we were looking for there, and that's choice A on number 23. Okay, we move on to figure number 3. And in figure number 3, we're given a bunch of information for the whole set of problems, which I will mark on here. We're given that KQ and KN are both 5. So there's KN, it's 5, KQ is 5. Okay. We also have the measure of arc MO is 100. And the length of SQ is 12. Okay. Well, the fact that KN, and this is circle K, it told us in the picture, in the information, which lets us know K is the center. When a chord, or when a diameter, or even just part of a diameter, like KN, hits a chord at a right angle, is perpendicular to it, that's the distance from the center to the chord. When two chords are the same distance, those two chords are congruent. So we know right now that segment MO will be the same length, be congruent to segment SP. Also, if two chords are congruent, then their arcs will be congruent. So we know that arc MO is congruent to arc SP. That means that arc SP in this problem will be 100. Another fact is that when a part of a diameter hits a chord at a right angle, it bisects the chord. It divides it into equal pieces. That sets off a lot of stuff for us. We would know that if that's 12, that's 12, and so are these other guys. We would know that not only are the chords cut into equal pieces, so are the arcs determined by their chords. So this 100 becomes 50 and 50. That's enough to answer a lot of the questions here. Let's see what we've answered so far. On number 24, we want the measure of arc SR, and you see I've marked that at 50, so choice C is correct on 24, 50. Number 25 wants the measure of arc SL. Okay, we're going to use the fact that arc RSL is a semicircle, being 180 degrees. So if I take 180 minus the 50 that you see right there, arc SL will be 130 degrees, and that's choice A. Number 26 asks for the length of segment MO, and I hadn't put a little 12 down there, but it's going to be 12 plus 12 is 24. That's choice B on number 26. Number 27 asks for the length of segment KL. Now notice that KL is a radius, so it's equal to any other radius that I can figure out. Well, notice, for instance, since it's easy for me to draw here, that segment KS is a radius, and I would have a right angle right there. If I put a variable like x, then I've got the Pythagorean theorem set up. 12 squared plus 5 squared must equal x squared. I'll leave it for you to solve that, but that's going to be x being 13. So every radius in this picture, including KL, is 13. So number 27 is C, 13. RQ, segment RQ. Well, got to be a little smart about this one. We just figured out that KL was 13. KR is also a radius, so it's also 13. If that part of it is 5, then RQ or QR must be 8. That's choice D on 28. And number 29 asks, what do arcs PO and LM add up to? All right. Well, if you look at the lower part of this semicircle, and I'm starting here at R, I'll highlight this in red. There's a semicircle. We know that up part of it is 100 and that part of it is 50. So we've used up 150 degrees. Arc LM and PO are the only arcs not in the 150 part. So if I take 180 minus the 150 for the two arcs I do know, then the two arcs I don't know must add